It says that we have a hyperbola given to us. Now you can see it's a hyperbola that has translated a bit. It's translated to the left and upwards. The two asymptotes have moved along, so the asymptotes cut here at point P. The first question that they ask us, this question comes from Huitsemang Pollen. Huitsemang, thank you for this question. It's beautiful. I'm going to show you a nice way to answer this question. Okay, so let's have a look. They told us that this is the given equation. Quite a strange way to give you the equation of this hyperbola. Now, they were quite sneaky here, folks, because we do not have, let me use a blue there, we do not have, let me use a black there, a horizontal asymptote, but we do have a vertical asymptote. So that tells us the value of P. This is -1 over here. And we know that whenever we're working with an, let's say, x plus p plus q as a standard form, that this component creates the vertical asymptote. Okay? So we know that the vertical asymptote is at x equal to -1. So look at this. X is equal to -1. Well, what does that tell me? It tells me that x plus 1 equals 0. Okay, so what is P? We can immediately see that P is -1. Now let's go and let's kick it into the equation. So we get f of x is equal to x minus d over, what is it, x plus 1 in our denominator. Now folks, here we've got to be very careful. They also now gave us a point. They told us that the point B lies on the hyperbola. And that's the point that we get if we let the y value equal 0, and then the x value, which is the x-intercept, will be 2. So in a way, they're saying to us that f of 2 is 0. Now, the only thing, if we do that and we look at our equation, we can see that if we substitute x with 2, and the x with 2 here, and the y value with 0, we only have d left. So let us take the point 2, 0, and let's hoy it into that equation. F of 2 is 0, which is equal to x is 2, so 2 minus d, divided by, the x is 2, 2 plus 1 is 3. Now look at the beauty here. 3 times 0 is 0, so therefore 2 minus d is 0, which makes d equal to 2. Okay, so we've got P and we've got D. P is -1 and D is equal to 2. Now the nice question, this question I loved. They say to us, show that this takes on a particular value. In other words, we need to rewrite this thing here so that it looks like that. Now remember, we just got D. So we know that this is x minus 2, and in the denominator we know we have a x plus 1. So that thing we must change so that it looks like this. Now let's see, how do we do that? We know that y is equal to, what did we say? X minus 2 at the top, yes, over x plus 1. X minus 2 over x plus 1. Now folks, we've got to manipulate this. And this is what is nice about this, Huitsemang, is that you need to only keep the x plus 1 and split the top up. So the denominator we don't want to touch. But to be able to get rid of that x at the top, you need to play with what you have in the denominator. Now look at this. If I break this up and I say this is x plus 1 over the x plus 1, okay? I have x plus 1 at the top. What did I have? I had x minus 2, so I must minus 3 over there. And that's how your split is going to happen. You're going to split it over this term. You're going to keep those two together, If you keep them together, x plus 1 over x plus 1 is 1, minus 3 times, or 3 over x plus 1. And there is your new hyperbola. A very clever and convenient trick that you can pull there is just to split that numerator up, and then you create the denominator from there. That was for another 2 marks. Now they ask you to write down the coordinates where the two asymptotes intersect. Okay, and that's quite easy. The asymptotes we know intersect at 2 at that point P rather. We do know that this asymptote, from the way in which we wrote this, is y equals 1. So the asymptote here is now y is equal to 1, and this was x equals minus 1. So point P will be the point minus 1 and 1.